Notes 12D. Sequence rules. Objective. I can write an equation for arithmetic and geometric sequences. Essential question. How do I use patterns to write a formula for geometric and arithmetic sequences? Here are your formulas. Recursive arithmetic. A of n equals A of n minus 1 plus D. Explicit arithmetic. A of n equals A of 1 plus D times n minus 1. Recursive geometric. A of n equals A of n minus 1 times R. Explicit geometric. A of n equals A1 times R to the n minus 1 power. Where A of n is the current term, A of n minus 1 is the previous term, n is the current position in the sequence, A1 is the first term, D is the common difference, add, subtract, and R is the common ratio, multiplying and dividing. Now recursive requires the previous term to be known. And explicit, you don't have to know the previous term, you only need to know the first term. Let's practice applying the explicit arithmetic sequence formula. If our 10th term is 64 and our common difference is D is 4, what is the first term? So we know that our current number is 64. We have 10 terms. Our common difference is 4. We want to find the first term using that given information. So to do that, we're going to plug it into the formula. So we have 64 equals A of 1, which we don't know, plus 4 times 10 minus 1. 64 came from the A of n. We were looking for the first term, A1. The common difference is plus 4, and our number of terms is 10. So let's solve for A1. So we have 64, we bring this down, equals A1 plus 4, 10 minus 1 is 9. 4 times 9 is 36. Bring everything else down. Now we want to get the A1 by itself, so this plus 36 has to be eliminated so it goes to the other side. To get rid of a plus 36 on one side, we need to subtract. We need to use the additive inverse. And whatever we do to one side to keep it balanced, we have to do it to the other side. So 36 minus 36 is 0. And then we have 64 minus 36, 8, and 2. So 28 equals A1. Our first term should be 28. Now let's practice an explicit geometric sequence example. If our 5th term is 1 and our common ratio R is 1/2, what is the first term? So our A of n is 1. We're on the 5th term, so n is 5. Our common ratio R, we're multiplied by 1/2 each time. And we're looking for the first term. So let's plug it into this formula. So A of n is going to be 1. 1 equals A1, which we don't know what that is yet, times 1/2 to the 5 minus 1 power. So we've plugged in all of our givens and we're going to find the first term. So let's go ahead and simplify this. 5 minus 1 is 4. If you remember from your exponent rules, this would be 1 to the 4th over 2 to the 4th. One to the 4th is just 1, and 2 to the 4th is 2 times 2 times 2 times 2. That's 16. So rewrite it over here. We have 1 equals A1 times 1/16. We want to get rid of that 1/16 on this side, so let's multiply by the reciprocal, 16 over 1. Each expression, not just that side. So that's going to be 1. 16 divided by 16 is 1. 1 divided by 1 is 1. 1 times 1 is 1. So we have 16 equals A1. So 16 should be our first term. Let's look at this word problem. Billy is stacking alphabetic blocks in the pattern shown at the right. The number of blocks in each stack represents the terms in a sequence. Which rule represents the sequence? So, this is our first one, and we have one block. So we have number of blocks, and we have the n as in the term and the position in the sequence. So on the first stack we have one block. In the second stack we have 2 blocks. In the third stack we have 3 blocks. In the fourth stack we have 4 blocks. And in the fifth stack we have 5 blocks. So it looks like n and the number of blocks is going to be the same every time. So our rule has to be f of n equals n. Let's look at these. So if we use this one, it would be 2 times n. 2 times 1 would be 2. That doesn't work. N plus 1. So if we have 1 plus 1, that would be 2. That still doesn't work. And 1 plus 2, that's not 1 either. Okay, let's look at another example. Given the sequence 1, 6, 11, write an equation to find the nth term of the sequence. So each time it looks like we are adding 5. Let's see, 1 plus 5 is 6. 6 plus 5 is 11. So that works. It works for both of these. So this is the arithmetic sequence because you're adding or subtracting. So we're looking for the nth term of the sequence, so n is just going to be n. Our common difference is plus 5. And our first term is... So we have a of n equals a of n minus 1 plus d. And our common difference is 5, so we're going to put plus 5. That's our recursive formula for the nth term. Now the explicit you'd plug in for this formula. A of n equals the first term, a1, so 1 plus 5 parentheses n minus 1. And you could simplify this one as well to get a of n equals 5n minus 4. Either of these could show up as an answer choice. Let's look at the next one. Given the sequence 19, 14, 9, write an equation to find the nth term of the sequence. So, looks like we're going to be subtracting. So minus 5. 19 minus 5 is 14. 14 minus 5 is 9. So our common difference is negative 5. And our first term is 19. And n is just n because you're looking for the nth term. So we're going to do the recursive formula first. So that's this one. A of n equals a of n minus 1 minus 5. We subtract 5 each time to get the next term. Now, an explicit formula, you'd plug in this. A1 is 19, so 19 minus 5, parentheses, n minus 1. This is also known as A of n equals negative 5n plus 24. Given the sequence 3, 9, 27, write an equation to find the nth term of the sequence. Well, it doesn't look like we're going to be adding or subtracting here. This is going to be a geometric sequence. 3 times 3 is 9. 9 times 3 is 27. So our common ratio is 3 because we're multiplying by 3 each time. Our first term is 3. And let's recall the formulas from before for recursive and explicit geometric formulas. So we recalled our formulas. We have A of n equals A of n minus 1 times r for recursive formula. And then for explicit, we have A of n equals A1 times r to the n minus 1 power. Remember, recursive, you need the previous term to know the next term. And for explicit, you need to only know the first term. So let's plug these in. A of n equals A of n minus 1 times 3, because we're multiplying 3 each time to get the next term. And explicit, A of n equals the first term, A1, times r, which is 3, to the n minus 1 power. Let's look at one more example here. Given the sequence 2412, 804, 268, etc., write an equation to find the nth term of the sequence. So this is also a geometric sequence. So each time it looks like we're going to be dividing a number. We're going to be divided by 3 each time. But we don't want to put divide by 3. We want to put times 1/3. We want to do repeated multiplication, and multiplying a fraction like this is the same thing as dividing by 3. So our common ratio is to multiply by 1/3 each time. Our first term, A1, is 2,412. So let's plug these into the formulas to get our recursive and explicit equations. So we have A of n equals A of n minus 1 times 1/3. That's our recursive formula. And for our explicit formula, we have A of n equals 2,412 times 1/3 to the n minus 1 power.